We're going to start talking about something called the product rule for derivatives. I'll just say product rule, but this is specifically for taking derivatives of functions. All right, so let's consider a function like this for a minute. Suppose you had f of x equals x squared plus 2 times x squared minus 3. And you were asked to find the derivative. Okay? So I'm going to offer two ways that someone might proceed. Right now, the only thing that you've been introduced to, or let's assume you only know about this thing called the power rule, that if you have a number times x to the n power, then the derivative of that number is k times the exponent, x to one less of an exponent. So you subtract one from your exponent. So we all know this thing called the power rule. Okay. So one option you have to answer this question here would be, let's multiply this out first, and then take the derivative of what we get. So if we did x squared times x squared, we get x to the fourth. And then we would have x squared times minus 3x squared. And then plus 2x squared, and then minus 6, which would end up simplifying to x to the fourth minus x squared minus 6. Okay. We know that what we're doing right now is going to produce a correct answer. Here's why we know that. Because this expression and this expression are the same thing. We know how to multiply binomials, right? We also know how to take the derivative of things like this. Well, the derivative of things like this, we use this power rule over here that we remembered just a moment ago. You'd have 4x cubed minus 2x. Well, there you go. This thing must be the derivative of f of x. So, let me propose a way that some of us may have looked at this. Ready? We had f of x equals x squared plus 2 times x squared minus 3. And what someone may have done is say, hey, I'm not going to multiply those first. I'm just going to take the derivatives first and then multiply the answers and see what we get. So if we take the derivative of this first piece, we get 2x. And if we take the derivative of that second piece, we get 2x. And then when we take the product, we get 4x squared. Now there's a question mark to be here. Because if we recall from the previous page, let's go back and look at it for a moment. The derivative was 4x cubed minus 2x. Okay? So clearly these two things do not equal each other. Well, something's wrong. Because we know that this has to be correct. We know it has to be correct because we did it using all kinds of things that we've made sure of before, right? We know how to multiply trinomials and get an answer like we did here. And then we've already learned how to take the derivative of this, use the power rule. So clearly this trick of taking the derivative first and then multiplying the answers doesn't work. Okay? So what that means is that when you're taking the derivative of a product, you need a special rule. Okay? So that's what we're going to find now. All right. So here's what that rule says, and then we'll prove it later maybe. The rule says if you have a first function times a second function, right? Or you can say f of x times g of x. I'm sorry, let's use different letters because let's do h of x here. So suppose f of x equals h of x times g of x. Then here's what you have to do. F prime of x, the derivative of a product. If you don't want to multiply them first like you did in this problem, then you can do the following. It's the first function times the derivative of the second function plus the second function times the derivative of the first. So this thing here is called the product rule, and it sort of seems strange. It's like, why would that be true? We'll get into that in a moment. I'd like to see it even work. I'd like to make sure it works. Right? So let's go back to the example that just gave us trouble a moment ago. So let's consider we had f of x equals x squared plus 2 times x squared minus 3. Okay? Now, we know that the correct answer, just to remind you, is supposed to be this, 4x cubed minus 2x. So we know we're supposed to get f prime of x equals 4x cubed minus 2x. So I'd like to see this product rule give us that. Okay. So let's do a little matching up here. If you notice, here's f of x. It equals a function times another function. So this thing here is acting like h of x. and this thing here is acting like the g of x. So let's give this a shot. According to the rule, f prime of x is supposed to be h of x, here you are, so it's just going to be x squared plus 2 times g prime of x. There's g of x. We're supposed to take g prime of x right there. So the derivative of the second thing is 2x plus, and then g of x, which is the second function right here, so x squared minus 3 times h of x, or I'm sorry, h prime of x, the derivative of the first function. So we're going to take the derivative of this thing, which is 2x. Let's finish off. Well, this doesn't look like the answer I was expecting yet. Let's do a little simplifying and see what happens. So I can multiply this 2x by both terms, and if I do that, I'm going to get 2x cubed plus 4x. And then over here, I can multiply 2x by both terms, and if I do that, I get 2x cubed minus 6x. Oh, wow, look at that. 2x cubed plus 2x cubed is 4x cubed. And then 4x minus 6x is minus 2x. Wow, that worked out. It matched what I expected. I have a slightly different way of remembering this. Generally, I'll be honest, I don't remember it this way. I try to think of the function like this. So let me show you what I mean. If a function is a product of two functions, I think of it as like a first function times a second. Okay, there's always going to be, right, a first function multiplied by a second function. And then the derivative, here's how I remember it. It's the first function times the derivative of the second. So this little d here means derivative in my mind. Plus the second function, derivative of first. So I literally read this like first d second plus second d first. First d second plus second d first. And that's how I remember how to do these derivatives. Let's use it. So here's a function, f of x equals, and I'm willing to bet that if you looked at this thing, this might be a problem where you would not feel like, now it looks like I really umped the ante all of a sudden. I made it much harder than it was, and it really isn't. I picked this question because I don't think anybody really feels like multiplying this out, distributing all these powers together and combining like terms. I feel like people don't want to do that. So instead, I'm going to think of this as the first function, and this is the second function, and I'm going to go figure out f prime of x. I can't promise you it's going to be nice to look at, but we'll be able to do it. So here we go. First d second. So the first function is copied over again, times the derivative of the second. Now, just as a little side note here, we should probably think of this as x to the 1/2 power. Oops, sorry, it's a little sloppy. And that should be thought of as x to the 1/3 power. All right, so now here we go. The derivative would be 1/2 x to the negative 1/2 plus 1/3 x to the negative 2/3. That 2/3 is coming from 1/3 minus 1. 1/3 minus 1. Or 1/3 minus 3/3. So you can see that's not very nice to look at. All right, but that takes care of the beginning of the derivative at least. There's first. And this part here is the derivative of the second, or d second as I've been calling it. Okay? Plus second function, so square root of x plus cube root of x, d first. Well, the derivative of the first function is 3x squared plus 14x plus 11. And then that's it. This thing here that we have is this whole big expression, which is a little wacky to look at, is the derivative of that function I wrote up there in blue. So here's a fun question. All right, so what we've shown is that if you have f of x equals first times second, then we know the derivative, right? It's going to be first d second plus second d first. So, but here's a good what if. So what if f of x was equal to a first function times a second function times a third function? And the question is there a product rule for this? And the answer is, if we're clever about it, we can actually use this rule up top again. We'll be able to use this rule again if we're clever about it. So here's what I'm going to do. I'm going to think of these two things temporarily as like a first function, and this thing as a second function. And then I'm going to use the product rule on this. But I'll have to be careful. You'll see in a minute. So here's what happens. So the rule works. F prime of x would be first d second. So first would be first times second. And then the times d second, so that would be derivative of the third. Okay? So there you go. This is temporarily, I'll make a little note. This is first, and that's d second. Okay? Think about what I'm doing there. Look at my green brackets up here, and you'll see what happens. Now, here comes the fun part. Plus the second function, which is the third, really. Okay? And then we have to do d first. But when we go to do this d first up here, you have a realization. You go, uh-oh, that needs a product rule. So it's a product rule within a product rule. So here it goes. Ready? Here it goes. So I'll put a bracket here. So that part's actually easy. So that's just first d second plus second d first. And then this big expression you end up with at the end is the product rule for a product of three functions. All right, so let's just try one more example. I'm not going to do an example of a function, a product of three functions, but consider this. Suppose you had f of x equals sine x times 1 plus x squared. If you want to take the derivative of this thing, this is an example of a problem that even if you tried to multiply it out first, you still wouldn't get rid of the product rules. Actually, if you tried to multiply this out first in an effort to avoid product rule, things get worse. Let me show you. You'd end up with sine x times 1 is just sine x, plus x times sine x, plus x squared times sine x. So in your effort to avoid the product rule, what you've actually done is made yourself have to do it twice. There's a product rule there, and there's a product rule there. Because you have x times sine x. You have two functions being multiplied. Here you have x squared times sine x. That's two functions being multiplied. So you're better off just leaving this in its original state and using the product rule. So it's first d second is going to be the derivative of 1 is 0, the derivative of x is 1, and the derivative of x squared is 2x, plus the second function. And we just learned that the derivative of sine x is cosine of x. So that happens pretty quickly. Here's the product rule at work again. We've discussed product rule. The question is, why does it work? Okay, that's what we want to do. We want to sort of prove product rule. Here's basically what it says. It says that if you have a function u times v, and this thing means take the derivative of. That's what it means, differentiate. Then the following is true. That the derivative of a function u times v is the u function times the derivative of the second. You might have thought of this as like first d second, right? Plus the second function times the derivative of the first. That's usually how people memorize it, first d second plus second d first, but I'm using slightly more sophisticated notation. Okay, so d dx just means take the derivative of. So the question is, why is this true? Okay, and in order to do it, I'm going to start with the definition of the derivative. So here's our proof of this little fact here. Okay, so we're going to say d dx of u times v is equal to the following limit. Now let's just back in time for a second. The derivative is really defined by this limit. The limit as h goes to 0 of f of x plus h minus f of x over h. So in our case, it's going to be the limit as h goes to 0 of u of x plus h times v of x plus h, because that's the function. The function is u times v, minus u of x times v of x over h. So if we can figure out what that limit equals, presumably it'll turn into this expression. That's what it's supposed to do. And this will be how the proof of product rule starts off. Okay? What makes this proof kind of fun, or I don't know if it's fun, but I'll say it this way. It's one of those proofs that when you look and see how it's done, you'll say, I never would have thought of that. I never would have thought to do that. So I'll start by asking you a silly question. Would you agree that if I added 0 to this numerator, that we would still have the same expression? And the answer is yes, you would agree to that. So watch what I'm going to do here. I'm going to write u of x plus h times v of x plus h. And I'm going to add 0 in a sort of a strange way. I'm going to do this. Minus u x plus h times v. Now that doesn't look like 0 to me. But watch this. Plus u x plus h times v of x. Well, if you look carefully, that's really 0. So I've added 0 to this numerator. I haven't changed the value of it at all. Okay. And then you have the following. Minus u of x times v of x over h. So what I'm claiming is that most people never would have thought to add 0 in this very funny way. Okay? But it's worth looking at a proof like this because there's other proofs that are written this way and they're just sort of fun. Okay. So let's take a look at a few things. So let's just look at this part of the expression here. So we have the limit as h goes to 0. And if you look at that, I'm going to separate it. I'm going to write u x plus h times v of x plus h minus u of x plus h times v of x all over h. So I'm sort of like separating these into two fractions. And then here's the other fraction here. That thing. So this is going to be, let's not lose that, let's say plus u of x plus h times v of x minus u of x times v of x over h. Okay? So what I've done is I've taken my original limit that I'm trying to find the value of, which is this thing, and I've rewritten it as this thing. All right, so again, not immediately obvious why I might be doing this. And let's just take a look at things in pieces. If you look at this red part of the sum, notice a common factor on top. See that? So watch what happens. I'm going to take that out. So you're going to have u of x plus h as a common factor. And what's left behind is v of x plus h minus v of x over h. Now don't forget this whole thing, we're taking the limit as h goes to 0. Okay. And now let's see if we can use similar reasoning on the second blue fraction. When we look in the second blue fraction, we look for something in common. They have v of x in common. So I'm going to take that out. I'm going to say plus v of x times, and then this is u of x plus h minus u of x over h. You might think, well, where does this leave us? Well, take a careful look at that. That should remind you, this kind of looks like the derivative. It looks like the derivative of v of x, right? That's exactly this limit as h goes to 0 of f of x plus h minus f of x over h. And we know by definition that that gives us the derivative. So this thing here is really v prime of x. Okay? And then using the same reasoning, what's that piece? So this piece is u prime of x. It's of the same format that this thing over here was. All right. So now the only other question is this. What does this thing become as h goes to 0? Well, if h goes to 0, you have u of x plus 0, which is just u of x. So watch what we finally have here when everything's said and done. This fraction, or this whole expression turns into u of x times v prime of x plus v of x times u prime of x. But that's the product rule, right? This is really saying the following. Remember, this is all equal to the derivative of u times v. So notice u is your first function and v is your second. So that's the first function. That's the second function. And here's the familiar thing. First d second plus second d first. So that's a proof of product.